Good morning. My name is Pauline Lucas and I'm the Policy Director at EUSEW2024, representing district heating and cooling. And a very warm welcome. Today is my pleasure to introduce this European Sustainable Energy Week session, co-organized by EUSEW2024 and the European Heat Pump Association. The session is called No Hot Air, the potential of waste heat for decarbonizing industry, cities and buildings. No hot air? What do we mean by this? Well, waste heat is not a buzzword. It's not empty talk or promise. It is a tremendous untapped potential. A recent study found that there is more than 2,860 terawatt-hour a year of waste heat accessible in the EU. And this is almost enough to cover the demand for heat and hot water in residential and service sectors. So on the way to carbon neutrality and to ensure our energy independence, while remaining competitive, this is a must to tap into this huge potential. And why is it a must? Well, heating and cooling is at the core of the energy transition. For instance, the building sector is 42% of the energy demand, and 80% of this is heating and cooling. When you look at industry, this is 26% of the energy demand, and 60% is heating and cooling. So both sectors are still largely driven by fossil fuels, and they are large greenhouse gases emitters. So waste heat is a lever to decarbonize heating and cooling in both of these sectors. Second, waste heat sources are local and available and ready to be used in homes, businesses, and industries. Did you know that a data center, when it processes data, 1 unit of this process is 1 unit of heat? Every city or town also has wastewater treatment plants. Every process that demands cooling also produces heat. So these are as many opportunities to harness heat, either at scale via district heating network combined with heat pumps, or on-site directly for industries. Third reason is that transforming our industry while remaining competitive will require us to lean on circularity and efficiency, and recovering heat that would otherwise be dissipated into the air is the exact definition of efficiency and circularity. So in this session, we will delve into the potential of waste heat. We will have 3 presentations that show concrete cases, successful cases where waste heat is recovered from different sources and for different applications. We will look at what are the challenges. If it would be easy, I guess we will not be talking about this today. And we will also explore the legislative framework, looking at the measures that have been adopted in the Fit for 55 package, and beyond this, the implementation and perhaps what else is needed to accelerate this transition and this waste heat recovery. So first, I wanted to engage with our audience here on site and also online with a Slido poll to the audience. So take out your phone and scan the QR code. So I first wanted to ask you a very simple question. What do you think is the biggest challenge to waste heat recovery? So first, the policy and regulatory framework. Second, stakeholder awareness. Stakeholders, we mean cities, operators, industries. Then third, perhaps the biggest challenge is the business model and the risk and the cost associated to this project. Or last option is whether there are some technical challenge and perhaps a lack of technology that would induce more needs for research and innovation. I'm waiting a few more seconds to let you time to answer. Interesting. Okay, it's still shifting a little bit. It's becoming tight between the two first options. A few more seconds and we can close the poll. And I'm also taking this opportunity to tell you that you can also use Slido in the room or at home or at your offices, wherever you're taking this session from, to ask your questions, because we will first have a panel, first have presentations, then a panel session to discuss with our presenter and panelists, and we will also have a time for Q&A. So be prepared and already put your questions out there on Slido. So I think we can close the poll and we can see, okay, you think that the biggest challenge to waste heat recovery is awareness, and second, business models. So I think we will discuss that with our panelists. But first, I will welcome Victor Ferré, Senior Director at Xylem, to talk about the water energy nexus case. Welcome, Victor.
Thank you, Pauline. So, first of all, thanks for this opportunity to talk here today at the European Sustainable Energy Week. I'm Victor Ferré, Director of Director of Vertical Marketing for Building Services at Xylem. Xylem is a global leader in water technology and services, and we joined Euroheat and Power and the European Heat Pump Association 2 years ago because we acknowledged that there is a role to play in the water energy nexus. So what is the water energy nexus? Basically, it's the codependence between water and energy. In order to produce potable water or processed water, you need a lot of energy, and vice versa. In order to produce energy, you need a lot of water, typically for cooling. So whatever solution we want to find for energy, we need to take water into account. And today I will present two cases that are close to us, close to our company, explaining how heat recovery has become a reality. So the first one is going to be about on-site recovery of industrial heat with heat pumps in Sweden at our Emmaboda manufacturing site. And the second one will be district cooling with treated sewage sludge in Qatar, so in Middle East. So let's start with Emmaboda in Sweden. This is one of our, let's say, flagship manufacturing sites worldwide. Last year we achieved what we call the sustainability triple crown for this manufacturing site. We use 100% renewable energy, we use 100% processed water reuse, and we achieved zero waste to landfill from processes. This has been a journey. The plant exists since a few decades already, 40, 50 years, and part of this success has been energy efficiency. We have a foundry that works all year round. And of course, it's southern Sweden, it's a cold country. In winter, we have a direct use for the waste heat coming from the foundry. But what happens in summer is that there are no heating needs, or not so many. So all this waste heat coming from the foundry should be sent somewhere. The first thought was sending it into the local district heating network, but it really didn't make sense because, again, the district heating network in summer doesn't have a lot of heating needs. So the next alternative was storing that energy in a borehole. So about 15 years ago, they started a project where they constructed a borehole system with around 100 drills, bores, going as deep as 70 meters, where they would just dump all this waste heat in the form of water, with the hope at the beginning, or as the calculations would go, that they would be able to recover it 6 months later when the winter season comes back. In reality, what happened is that they poured water at 70 degrees, and when they pulled it out 6 months later, it was only 20 degrees. So it took them 7 years, sorry. It took them 7 years to figure out how to fix that. In 2018, they installed heat pumps, and basically the heat pump was a game changer there. It allowed them to, first of all, inject the water in the borehole at much lower temperature. So they injected it at 40 instead of 70. And after 6 months, they could still pick it up at 35. So the drop in temperature was very low. And then at the time of picking it up, when winter came, they would just raise the temperature with heat pumps very efficiently at a COP, like coefficient of performance of the heat pumps, of around 4. So that allowed them to really recover around 57% of all that heat, which pretty much came for free. And as Pauline said, whenever a heat pump produces heat, there is also cooling being produced. So that cooling came as a bonus, something for free on top. So 7 years into the work, what you see is that the results are very consistent. So this chart here is showing the cumulative heat that is being used in the plant after it's taken out of the storage. So it's a cycle that lasts 12 months, obviously. 6 months, the system is charging the borehole. 6 months, the system is extracting from the borehole. You have some numbers here. So 3 gigawatt hours stored during the summer season, and 1.7 gigawatt hours recovered during the winter season. On the economic side, and that was also pointed out in the poll, does it really make sense? Does it really make sense economically and technically? Well, our data shows that the annual cost of running this system is 30,000 euros, whereas the benefit we get in annual savings by displacing this heat or saving this imported heat from the district heating network is 105,000 euros. So yes, it does pay off, and yes, technically it is feasible. It was a journey for us. It took us 15 years to get where we are, but fortunately now it's working well, and the heat pump was a key element in this. So that's the first example. The second example is not on site. This is a network. It's a network in Qatar. There's no reason why it couldn't be implemented anywhere in Europe, especially where cooling needs are a fact. This district cooling network uses treated effluent from wastewater as the main temperature source.
I want to give you this.
Okay, thank you. Can you hear? Is it okay? Yeah. So in this case, it's an open loop system. So you have to think about resource circularity. We're talking about Qatar. We're talking about the desert. You may not always have the sea line or the coast nearby where you can get this thermal energy from. You don't have rivers, certainly. So the treated effluent is a great resource here. It is used also in combination with chillers. So again, it's the same concept. You transfer thermal power, thermal energy of low temperature around the city with very low losses. And whenever you get close to the point of use, you raise the temperature with heat pumps, or you lower the temperature in this case because it's a cooling network. So that's pretty much what I wanted to say to start with. Water energy nexus, and yeah, the value of the heat pumps in this waste heat recovery.
Thanks a lot, Victor. I think it's very interesting to see this synergies, heating, cooling, water, energy. And now we're going to look into another example. So I will call Andrea Voigt, Vice President and Head of Global Public Affairs and Sustainability at Danfoss. Floor is yours, Andrea.
Thank you so much, and also thank you for giving us the opportunity to present here, and great to see the room is full, so really happy to be here. 2 words about Danfoss before I start. Danfoss is a Danish company headquartered in Denmark, but with global operations, global leader in energy efficiency and decarbonization technologies, over 40,000 employees worldwide, over 100 production sites, and very strongly rooted in Europe. So, how does this work? Okay, so I wanted to start, reflect 2 minutes about the potential of waste heat. I think Pauline mentioned it already in her introduction. There is a huge potential of waste heat, which remains unfortunately still untapped. It's 2,860 terawatt hours, just to repeat that number. And to put it a little bit into perspective, that corresponds to the total primary energy consumption, more or less, in France. So it's huge, but it's not being used. And it's surprising that it's not being used, because we do actually have quite a lot of bits and pieces across the Fit for 55 package, which gives a lot of angles to use waste heat and to boost waste heat. And I just tried to list them here on this slide a little bit. So first of all, we have in the Renewable Energies Directive, for example, the possibility to count waste heat or the use of waste heat towards the renewable energy targets in member states. So that is an opportunity, of course. Then to give another example, in the if we put it together with heat pumps, then of course waste heat can help decarbonize as well. For example, applications where we do have a lot of waste heat, like data centers, for example, and I think Pauline mentioned that as well in her introduction. And there we have a nice angle in the Energy Efficiency Directive as well, where we have those reporting obligations also for data centers, and that comes also to the point you see here. Reporting will put the finger on this potential and also create more transparency when companies can use, for example, waste heat to reduce their energy consumption or energy generation for heat. Then we have opportunities in finance. It can be counted to a certain extent within the EU taxonomy. Also there, still improvement necessary. And also more awareness, of course. Efficiency potential in heating and cooling, again, the Energy Efficiency Directive. So across those different pieces of legislation, I think there are quite a few opportunities to use waste heat and to make better use of that potential. But we still have a big job ahead of us, and that's also what the Slido intro showed, to raise more awareness about it and also to create the business case to really bring this to life. So I wanted to give 3 examples here, starting with a hospital which is in Sonneborg in Denmark. It's going to be officially not the hospital, but the heat pumps and the waste heat recovery is going to be officially inaugurated at the end of this month. And I think it's a great example to show how infrastructure, critical infrastructure, such as hospitals, can also benefit from those opportunities. In the past, the hospital was using some gas-fired, mainly heating and cooling. And now the intention was to really take advantage of the renovation of the hospital and integrate in these renovation endeavors also the heating and cooling side of things. And while doing so, really build on the fact that we need both in a hospital, heating and cooling, and to use that symbiosis between the two. So what happened there is that 2 heat pumps have been installed in that hospital, and those 2 heat pumps from Energy Machines and powered by Danfoss technology, they are working hand in hand to provide both the heating and the cooling. And the really amazing thing here is the total efficiency ratio. So if you take those heat pumps separately, or if you take heating and cooling separately, then you would have a certain COP, a certain coefficient of performance, around 3.6. But if you really combine the two and you use those synergies, then you double that coefficient of performance. And that, of course, is a huge potential for the hospital to save energy. And we all know that hospitals are very much under pressure in terms of reducing cost and reducing, therefore, also their energy consumption, because that translates directly into savings. So that is a huge opportunity, and on top of that, it creates a potential revenue path for the hospital, because the hospital does not need to buy so much heat anymore. I'll show you a graph afterwards. It can even sell heat at a certain point in time, because it can recover that heat from the cooling system. So, and also to say that this whole principle and site is in the city of Sonneborg, which has itself a sort of a project which is called Project Zero, and which aims to decarbonize the city of Sonneborg by 2029, and we are already more than halfway there. So it's not part of the Project Zero, but it's in the same sort of place. So there is a lot going on in that region, and specifically in the city of Sonneborg, which all tends towards decarbonizing the energy system. So just to show this, and I know it's a bit of a busy slide, and a little bit difficult to see what this shows, but I would ask you to focus on, first of all, on the yellow bars. So the yellow bars, that shows the heat which is being provided by the heat pumps, and the blue bars shows the cooling which are provided by the heat pumps. So you see, well, typically how this goes up and down over the year. Interestingly, if you look then at the purple ones, you see that heat, there is nearly no need to buy heat from the outside or from the district energy grid. You see that there is only a need to buy heat in the cold months, in the winter months, in January, in February, and in December. And for the rest of the year, you can see, starting in April, that actually heat can be sold. So heat can be sold to the district energy network. So that's very interesting for the hospital, of course. They don't have to buy heat during that time. They actually can sell heat, which is, of course, a very interesting approach, and also makes them more resilient, obviously, and less dependent. So just, as I said, it's a little bit of a busy graph, but I think it translates the message very well of how the efficiency of heat pumps can really be a great opportunity, specifically for critical infrastructures that need both heating and cooling, and where those opportunities can be combined with each other. And that's true for hospitals. It's true for any infrastructure where you need both. You can translate that to supermarkets. You can translate it in any other critical, like a slaughterhouse, for example. We have another case also in Denmark where a slaughterhouse, for example, that needs cooling but also heating for the hot water. So there as well, you need both. There are a lot of examples like that where you can combine them. Then I wanted to give the example of the supermarket. So this is part of our decarbonization park, if I can say so, in Norborg, where our headquarters is. This is a supermarket which is combined with a smart store application center. And that supermarket uses really state-of-the-art, latest technology, energy efficiency technology with CO2 as a refrigerant, which also then offers the opportunity again to recover the heat from the cooling installations, upgrade it to the temperature necessary, and use it directly on site. And if then there is still something left, then it can be fed into the district energy network, which goes around. So it really combines the two, using the waste heat on site and feeding it into the district energy network if there is more left. So same principle as for the hospital. And as you can see here on the other example, that's another supermarket which is also very interesting, which is close by. And both, by the way, are normal supermarkets, so it's not something special. It's supermarkets where you just go and do your grocery shopping. So the other one is a few kilometers away, and you can see that there also there is the the same principle, basically recovering the heat, and then the rest can then be sold to the district energy network and can be used by the houses surrounding, or the village which is close by. And then finally, my last slide is to show what we do in at the Danfoss headquarter campus. So at that headquarter campus, we have an integrated energy system, and the headquarter has been carbon neutral since last year. So, or since end of 2022, since last year. And it is really a prime example on how you can combine all of those different applications and make use of the waste heat and of the fact that everything is interconnected. So what we do on our campus is we use heat pumps, and those heat pumps, they provide the cooling in our office building, then recover waste heat from there. We have the Danfoss data center, which is on the campus as well. It's a modular data center, and from that data center, we also recover the waste heat from the data center and from the cooling, and it goes again into the grid. Then we have the supermarket, which is what I was just showing you, where we again recover the waste heat and feed it into the grid, the waste heat which is not being used by the supermarket itself. We have a Danfoss Power-to-X station. We recover the waste heat there. We recover the waste heat from the compressed air. It all goes through the Danfoss heat exchanger station. We use it to heat our office buildings, and the rest is then fed into the district energy network, which goes to the villages and the cities nearby. So it's really an example of how all of this can be combined in a meaningful way, and it comes also back to what Pauline was saying in her introduction, that we really need to take this integrated approach where we bring those different energy sources together and make use of them in the best possible way to decarbonize as much as we can, and also specifically industrial sites, which are, I think, one of the prime targets where we really need to make step change and to achieve that decarbonization. And just to end, we have this three-step approach which is applied in this integrated energy system, which is also applied by the city of Sonderborg in their Project Zero, and which is something that is perfectly replicable everywhere. And that three-step approach is to first, number one, reduce the energy waste. So use energy efficiency as much as possible to reduce the energy use, save energy. Number two is to reuse energy, and that's the whole waste heat story that I was just telling, which is a huge opportunity. And then number three, resource green energy. So once you've reduced your energy use, once you've reduced your waste heat, the remaining energy which will still be necessary, that remaining energy should then be resourced by green energy sources. So that's really a principle which can be applied everywhere, and we are just launching as Danfoss also a decarbonization trailer actually on LinkedIn. So if you're interested in learning more, just tune into our LinkedIn accounts. Thanks a lot, or into mine.
Thanks a lot, Andrea. And indeed, the best energy is the one we don't consume, and the second best is the one we recover and use. And very important point also on buildings. As we are renovating, let's take every opportunity to renovate buildings in a meaningful way where we can tap into these resources. But lastly, the third presentation with a different perspective, more focusing on industrial sites. So Valerio Forconi, Director, Government Relation and Public Affairs at Train Technology, will show us another example from a dairy factory. Welcome, Valerio.
Thanks, Pauline, and thanks to everyone. So just a couple of words about Train Technologies. We are a large multinational company headquartered in Ireland. We got 12 manufacturing sites across the EU. And we have two business lines. The first one is commercial and industrial HVAC. We produce chillers, large heat pumps, air handling units. And the second one is transport refrigeration, so the equipment that ensures that any perishable goods can be transferred from point A to point B under controlled temperature. So as introduced, I need the remote control. As introduced, we want to bring an example of a dairy factory. It can be, as previously said, really applied to any kind of industrial processes requiring simultaneous heat and cool. And traditionally, entering into the merit, traditionally, any dairy factory has an heating demand for processes like pasteurization, fermentation, sterilization, and cleaning, and a simultaneous cooling needs, essentially, for storage of finished goods and raw products. But I think the huge change, as was alluded in previous presentation, is really to try and combine the two systems, and let's see how. So here, as you can see, during the cooling phase, the wasted heat, instead of being dispersed into the atmosphere, is reused, recaptured, and repurposed and re-injected into the system, making the evident thing that the heat that is required doesn't have to be produced from scratch. So looking at concretely what it meant, so in our case study, as you say, the previous installation was a chiller plant and a boiler plant working in silo, isolated, and working independently one from the other. And the challenge that our customer asked was to reduce the overall carbon footprint and the water consumption from their operations. Yeah, so the solution our engineers provided was to install an air-sourced chiller, being able to, through an heat exchange, to harness 1.5 megawatts of heat at relatively low temperature, around 40 and 50, plus combine it, and this is the important passage, with an high temperature 0 GWP heat pump, producing hot water at roughly 95 degrees. So as a result, the outcomes and the benefit for the customers were the waste heat that was recovered allowed the customer to save roughly 125,000 euros per year, and the overall CO2 emission reduction was of about 10%. The heat pump enabled to reduce the fuel consumption by 15%, which saved the customer roughly 70,000 euros a year. And addressing the other objective of the customer was to be able to converting from steam to hot water, allowed to reduce the overall water consumption. So just to say, you may argue that, what's the big deal? I mean, you saving here 10%, 15% is not a breakthrough innovation. But we deliberately wanted to raise this case and present to you this case because the customer, for personal individual reasons, decided to keep the fossil fuel boiler plants to maybe address peak demands. The message here is that technology can allow to have a completely fully electrified thermal management system. And of course, in that case, the overall reduction of CO2 would have been much higher. The reason behind the decision of the customer is mainly a price one. So, and I think this is an important message we will discuss, but it was already alluded by previous speakers around the fact that helping customers and helping society to address this price gap will surely avoid any barrier to move to an all-electric, fully thermal management system. So that's it from our side. And to close, I think that as we already understood, moving to combine thermal management system is really a yes, both for the customers, but also for the environment.
Thanks a lot, Valerio. I will now invite our three presenters to join us for the panel, and we're also joined by two more panelists. So let me introduce you to our two other panelists. We are joined by Heine Weidenbach from the European Commission, member of the cabinet of the Energy Commissioner, Commissioner Simpson. And we are also joined by Arthur Hinch, senior expert, sustainable energy systems at ECLE. ECLE is the local government for sustainability network. Okay, we're just making ourselves comfortable, well seated for. All right. I will. Thanks a lot for the great presentation. I think it's important to see also with numbers what it means to save energy, but also what it means in terms of cost optimization concretely for industries, for companies. So it's very interesting. Now I would like to come back. Andrea already gave us a hint a little bit about what was adopted with the Fit for 55 package. We had 2-3 years of very intense work at the European level. And Anna, you're here to tell us a little bit more about what will be the key measure as part of this Fit for 55 package that will drive the wasted recovery.
Hello? Yes. So good morning, everyone. So I'm super happy to be with you here also towards the end of this mandate. I worked for several years in the energy efficiency world as a policy officer there, focusing on the energy savings obligation. And then we had already close contacts with many of you representing NGOs or stakeholders and touching upon this very important topic. I found it very inspiring to see these case studies, and I hope they are really spread the word with your case studies presented. Because it's key what you say about energy costs, about decarbonization. The key topic of our European Sustainable Energy Week from the Commission's perspective was how can it contribute to competitiveness? And you just named it, that especially energy-intense industries are cost sensitive and can react to energy prices, and you are enabling basically the energy-intense industry, but also other areas like you said, hospitals, supermarkets, food industry. You can really help to maintain the competitiveness. For our framework, I think it's now that we have a holistic framework, it would be good to hear more from you where you see further, let's say, needs to add or to enable further the waste heat recovery or waste cold recovery. So for now, we have the Energy Efficiency Directive. I think it's really key for the next steps of efficient heating and cooling systems. We have the requirement that member states need to come up with a comprehensive assessment of the heating and cooling system, but also for the local level for municipalities with more than 45,000 inhabitants to assess the heating and cooling needs. And there, in those two aspects, waste heat recovery or waste cold recovery is explicitly mentioned, and I hope that also municipalities will be able to assess the potential in a good way. Also, you can see in what the criteria for efficient district heating and cooling is. We will start in 2027 with a threshold of waste heat in this mix of 50%, and with our milestones agreed, waste heat as from 2050 can be considered as efficient district heating and cooling, or together combined with renewables. I think it is a clear message that waste heat is important and can contribute to also to our decarbonization goals. And then for you mentioned data centers. So the the idea is to target or to unleash the potential for waste heat recovery. And one of them is our data centers. The Commission published a delegated act in March this year to kick off with, let's say, fact-finding for the EU-wide scheme for data centers. And the idea is that also there the potential from waste heat can be fully unlocked. But it's not only about data centers, maybe important to mention, we also target other facilities. So be it for the electricity generation, or we explicitly mention LNG facilities or service facilities. We mention what was presented, wastewater treatment processes. And in this regard, I would also be, I had an interesting exchange just some before this meeting started about the new need to end dependencies from fossil fuel. And there we are, in addition to renewable energy, we are talking about a massive deployment of hydrogen. And there, I think also waste heat recovery can be a key role. And I think this is a new area for further thoughts, how we can use the process heat when generating hydrogen, but also how to make desalination processes more energy efficient and to recover heat there. So I think our basic message is for the Energy Efficiency Directive that the potential from waste heat recovery is detected, and you also stepped upon the Energy Performance of Buildings Directive, where it's clearly, if you see zero emission buildings, which should be the new gold standard for new buildings as from 2030, there clearly the co-legislators agreed on no on-site emissions, but also the importance to be connected to highly efficient district heating and cooling networks. If you renovate buildings, you just mentioned how important it is to do it in a smart way. So where to or how to connect buildings and where should buildings be located if you plan new areas where new buildings should be built. So I think there also in the renovation provisions, the possibility to recover waste heat by buildings will also play a key role. Yeah, and finally, I think it's also up to the energy performance certificates to be based on a methodology that takes into account the possibility to recover waste heat. And with this, I mean, these are just the main provisions. But I think my key message is that it's great that you present your case studies today and that you really spread the word to policymakers, but also to the member states level now, because they are working on the national energy and climate plans. They need to be finalized by at the end of this month. But even if some of the great cases you presented are not well known now, I think that it's still worth to present it to member states to show the savings potential in terms of energy efficiency, in terms of decarbonization, but also in terms of water savings that could be achieved. And with that, even if this is not, this cannot be implemented in the national energy and climate plans now, we also have the national building and building renovation plans according to the Energy Performance of Buildings Directive, and they have to be drafted in 2025. So, so please go ahead and share the good practices and all the potential behind. Thanks a lot.
Thanks a lot. And we do have a solid basis. We saw that awareness perhaps is not there yet. We saw it from our audience, and we heard it from Andrea. But indeed, we have the Fit for 55, we have targets that's setting a direction for renewables and waste heat. We have data, or we hope to have more and more data in the comprehensive assessment from member states, and we will have the plans from the municipalities. So this is a great basis. Before we go into what more could we ask for, because we know that there is a next mandate coming in with a new parliament, with a new commission to be. I would like to ask you, and I saw the poll is already online, through Slido, yes. Which policy measure, so among all the aspects Anna mentioned, what do you think will have the most impact? And what will be the most effective to recover waste heat? And I think it's been up for a couple of minutes already, an obligation on producers of waste heat. So yeah, we should steer producers, industries. This is also the matter of awareness, like what do I have to provide? So if there is an obligation like the one on data center, this can drive the recovery. But of course, now I see that the municipal heating and cooling plans and the comprehensive assessments are coming up as well. So we see this is a crucial part of the framework. Sectorial targets, we have those, okay. It's still moving, so yeah, we see our two core components, and I think this is great because this is out there. But let's go on to further to these measures that will have to be implemented. What can we ask more in the perspective of also increasing climate target for 2040 and being climate neutral in 2050? This doesn't work.
Yeah, thank you, Pauline, and thank you, Anne, for all the good input, which I think ticks nearly everything I've written down, so which is really good. But first of all, I would just like to repeat what we really do need is implement now. I mean, there is a lot of groundwork that has been done. In the past years. So now it's the time to really bring this to life, and I think that's also a little bit what came out in the Slido, like the heat mapping, for example, the plans that need to be drawn up by the municipalities. I think that will be an exercise which will, number one, raise awareness a lot at city level, and number two, which will then also show how can those different sources be connected to each other. So I think there we certainly have a very good angle, but of course then it shouldn't be static. It shouldn't be, okay, I'm making my heat map and that's it and I'll put it in my drawer. So then it's about also bringing it to life, actually. And that's probably where we still have a bit of a need to further improve, which also was the result of the first Slido and which also came out of this one now. It's this one. Where I think it's perhaps not so much in terms of obligations and requirements, it's perhaps also a few carrots that would be needed, not only the sticks. And those carrots can also be tax breaks, for example, if companies recover waste heat. It can be subsidies, for example, where this is rewarded by the municipality, for example, or by related stakeholders. It can also be a possibility to include the savings from the waste heat into white certificates, for example, which are energy saving obligations under the Energy Efficiency Directive. I think there are quite a few things that could be done to further drive the uptake of waste heat aside from obligations. So that's one thing I wanted to say, so the carrot side of things. The second point I wanted to raise is that there is a lot indeed in terms of waste heat related to district energy, and that's great. And also as shown in the slides is something that we, for example, in our own campus and municipality apply. But then there should also be a bit more attention and focus on what Valerio, for example, was saying on the waste heat recovery on site. So even if there is no district energy around it, or consider also smaller district energy grids like microgrids, where you would have just a few buildings that are, or just a few industrial sites that are connected to each other. So there maybe could be some improvement in terms of the regulatory framework that is available, to further extend that also to those microgrids, where I think there is a huge potential which is not tapped for now. And that also then comes with the awareness, I think. So make really help driving campaigns and seminars and educational sessions with member states, as you were just saying, Anne, but also possibly with associations to reach industry and make them aware about the business case of waste heat recovery, which is something that came up in the first Slido as well. Because if I'm just taking our own example, we wouldn't have decarbonized our campus, and we wouldn't have put in place that integrated energy system and the energy efficiency measures and this approach, which I said earlier, of reduce, reuse and resource, if it didn't make business sense. All the measures that we have implemented at our headquarters, they are paid back in around 3 years. If that hadn't been the case, it wouldn't have happened. So it's not as if it's something which is abstract and which sounds great, but which doesn't represent any value for businesses. It actually does. It pays off. And that's, I think, a message that is not enough known. So that's something which also needs to be further spread as a message to draw the attention. And one last point, which is also something maybe which doesn't get the attention it deserves for now, is that we will have all those reporting obligations, the sustainability reporting obligations in the Corporate Sustainability Directive. And in those obligations, companies will have to declare or disclose their Scope 1, Scope 2, Scope 3 emissions. And the Scope 1 and Scope 2, if I'm reusing as an energy-intensive industry, for example, if I'm reusing my waste heat on site, then this will have also a positive impact on my Scope 1, Scope 2, because I will then need to buy less heat. So that also, and that will become much more transparent. So it's a real benefit for the companies, which I think would also deserve some further education and awareness raising. So a lot of stuff that can still be done, not necessarily adding a million new requirements, but more rewarding and supporting the uptake of waste heat and educating the market on the business case.
Thank you, Andrea. So more carrots than sticks, but inherently this circular processes are paying off. So that's very good news, and I think it's important. And what we're doing today, I like to point this out. And also an interesting message, and I guess we will get back to this on the on-site. Eventually there is waste heat, enough waste heat to recover it on-site, to export it to district heating, and I see there are also other questions on this, so we will tackle that in a moment. But we saw that the municipal, the local components is very important. We know that cities are front runners. We have the city missions. We have 100 cities that have pledged to become carbon neutral by 2030. This is not only for heating and cooling, obviously, but heating and cooling is a big part of this challenge. Now I would turn to Arthur, coming from being here in this panel, the representative of local and municipal authorities. We see that there are many of these plans, many of the cities that have adopted decarbonization plan, climate plans. This is starting to already be successful. But how can we scale up this kind of strategy and encourage more cities to adopt strategies for heating and cooling, for decarbonization? What is needed from the local perspective?
Yeah, thanks a lot for the question and for the Am I hearable? Yes, now I'm hearable. Okay, hello everyone. Indeed, so Arthur from ICLEI, we're a global network of local and regional governments for sustainability, and deal also a lot with the topic of heating and cooling, and specifically here what is needed from the local level. Well, it's about holistic and strategic planning. I think that is what the role of local authorities is when it comes to fostering the most effective use of, well, waste heat, or creating effective district heating systems around heating and cooling. And here I think it helps to understand a little bit what the fundamental role of public authorities with regard to decarbonization efforts tends to be. And I think a lot of it resolves around what I mentioned, this strategic and holistic approach to getting many different stakeholders around the table and trying to understand across different sectors, across many different stakeholders, what exactly are the challenges and how can we synergize in terms of the contributions of different stakeholders within this municipal context to achieve those decarbonization targets. So specifically, as you've mentioned, of course, cities set themselves climate and energy plans, where they would like to be at a given time frame to decarbonize their system. Similarly, while these plans tend to be rather holistic and try to encompass heating and cooling, but also go beyond that, as you said, there is also now, from the European level, the obligation to member states, where member states are strongly encouraged to have municipalities over a certain population threshold, I think it's 45,000 or something, to implement these heating and cooling plans. And that is great, because the moment you have that as a municipality, you kind of have the mandate internally to, make the machine running, essentially, to ensure that you can actually credibly get the stakeholders around the table and implement something. That's a very first important step. But here I think it's important when we talk about these obligations for municipalities to implement such heating and cooling plants, it's important to understand the context until now. I think when you look around Europe, the framework in which municipalities operated when it came to the kind of planning for heating and cooling is very different, right? So many in certain countries, like the Netherlands, for instance, municipalities were already longer encouraged to do these kind of plans, and then they were actually centrally supported by a central government agency in the data gathering process, in actually kind of the planning process. In Germany, for instance, that's different, right? In Germany, it depends on the federal state. So, for instance, the federal state of Baden-Württemberg has these obligations for larger municipalities and provides funding for municipalities to be able to do that. But very importantly, the planning of the local heating and cooling solutions is the responsibility of the municipality itself, which means the municipality has to actually have access to all the data, needs to be able to talk to all the stakeholders and actually make this coherent approach. So that is important. That's a departure point. So I think going forward, when we expect more municipalities to do that, we need a clear approach to how this can be most effectively done. And here, I would like to explain to you a little bit about the structured approach, which we, from our side, as ICLEI, together with other partners, are promoting, that municipalities use, which is the act on heat kind of strategic approach to heating and planning. It's a holistic work plan approach that is based on the integration of data mapping tools such as hot maps and thermos, which have been very actively used already since a couple of years in this field. And the basic idea being that we understand that municipalities are the conveners of different stakeholders. They create the vision in terms of where they would like to go in the long term. They have long-term decarbonization targets, of which heating and cooling are a part. They create a commitment with different stakeholders, and then you would create some kind of heating and cooling working group where you get the different stakeholders, local companies together, businesses who can deliver on the technical side, to talk about the business model, the feasibility, and where specifically you would like to create a district heating network, a sustainable one. How do you feed it, what kind of sources, but also, where's, for instance, the waste heat potential. Then you would create some kind, you can divide this model into like two steps. So basically there's the city planning element, where the city is responsible for, talking about stuff like zoning. So where you basically try and on one hand, find out, okay, where's the potential for delivering heating but also what is the demand of, for instance, residential buildings or industry buildings that would be the customers of such a district heating network. So you create the kind of inventory and potential mapping, you would do the zoning exercise, and then together with the stakeholders, you would create some kind of scenarios, technological scenarios to think where can you go feasibly in the long run. And this needs to be consensus around that, and the city would convene that. So that's the first step. And then you take all of that and you create some kind of heating and cooling transition strategy, which can be like a roadmap document for certain milestones in terms of where do you want to be in a certain sector and at what stage and what specific policy measures would you set in place. And then you look at project feasibility, financial feasibility as well, the concrete planning of a concrete specific project, district heating project, and then you implement it. And at the very end of that, you kind of review and you upscale and you improve, you can start the process again. So the basic idea here being is that you have all these steps, that the city is at the center of the kind of convening process, and you're able to connect to different sectors, so via zoning approaches and spatial planning approaches to different sectors, to different stakeholders, and the city convenes all of them, and basically by that you ensure that you're actually able to meet these obligated plans, and that is very important. And of course, these plans are fed by these tools, like when cities struggle with data access, for instance, there's tools such as Thermos, which gives you a very good idea in terms of where can you implement a district heating network. Also, what is the business model behind it? You can take, quite literally, you can go to the website of the tool and you can actually look at your city. It uses different kind of GIS data and open source data. And you kind of look at specific geographical elements of your context, and you can look at, okay, based on the buildings, what is their potential heat demand, etc. But also you can look at the business model that is associated with that demand, in terms of how cost-effective is the supply of the heat going to be via the district heating system. But also you can take a whole systems approach where you also would take into account, okay, if the city would actually encourage the renovation of all of these buildings, how would that affect the business model behind the provision of heat, and also how does that then correspond to the overall kind of heating and cooling, but also decarbonization targets that the city has as part of its sustainable energy and climate plan, for instance. Yeah. So it's all about holistic models, and that's very much the message that we would like to drive. For all the municipalities and urban planners watching here and in the online audience, please be aware that the Act on Heat project until the 25th of June has actually has an open call to receive technical assistance on how to implement this holistic planning approach for heating and cooling. Very, very, very concretely, we'll guide you through all these steps, all these technical questions that you have. You will get special access to these tools. And there's a very skilled team to support you with that. Specifically, if you're a municipality asking, okay, we have the obligation to organize these plans, but how can we actually do it? We can support you for sure. So deadline 25th of June, please do apply.
Thanks a lot, Arthur, and great call. I think now it comes to making these plans and also not leaving them in drawers. So I think you pointed out it's very important to have this support, like all the feasibility phase for this project to get off the ground, and then also what happens next. And you also pointed out, I think, a core element, and this gives me a segue into my next question. You talked a lot about business models. We know that it's a crucial issue. We already see some data coming out of your presentation on how it can benefit different industries. So I wanted to explore with you, Victor. You talked about the water energy nexus, and I'll highlight this synergy and this interconnectedness between water and energy. So I wanted to ask you if you could dig deeper into why is it important to foster this synergy, in particular the connection between the energy efficiency and how we can save costs and improve the business models for these industries.
Yeah, thanks, Pauline. So, obviously, water is always considered cheap here. I want to talk about water again. We have to recognize that water may be a limiting factor for energy generation. And the way our current energy generation is set up in Europe is around water cooling. Water cooling is typically around rivers. So it's a very, let's say, static infrastructure that we have built. And we are taking this water for granted. This water was designed, or like those plants were designed a long time ago, and that river flow was taken for granted. In the future, or we see already in the present, that's not the case. Climate change is starting to play a role, and this will impact water availability, this will impact energy security, this will impact costs and viability of energy projects. So recognizing that this is the limiting factor, possibly the most important limiting factor to energy generation is there. We need to find a way to make the energy sector less water intensive. Right now, the energy sector consumes as much fresh water as agriculture in Europe. That to me is mind-blowing. Always thought that agriculture was the most water-intensive activity we have in Europe, but the energy sector is right there, which is, by the way, 50% more than the municipality water consumption for our human needs. So it's really the one elephant in the room to address. So that's one fact, recognizing the limiting factor. The other one is recognizing wastewater as a resource, as a waste heat resource. We saw in the heat maps in all the communities that there are always, the waste heat is concentrated in a few points, in a few infrastructure that is really scattered across Europe. And one of those infrastructures is always the wastewater treatment plant. So right now we have wastewater treatment plants pretty much in every community in Europe, fortunately. So we should recognize that this has a lot of potential for waste heat recovery. Science says that the energy content on wastewater is 5 to 10 times the energy needed for treatment. Today we are consuming energy to treat the wastewater. But with a little bit of vision, we could turn this around. So the wastewater treatment plants could become energy centers. They could be efficient energy centers. So there are different ways to recover that energy. Let's say the most immediate would be biogas. So if you have, let's say, anaerobic digestion at the end of the process on the sludge, you will create biogas that then you can use in cogeneration plants and then export into district heating networks, for example. But that's not the only way. There's also sludge incineration. Today in the EU, we dispose 30% of the municipal sludge in landfill. Why do we do that? Are we rich? Do we have too much energy? Sludge has the same power, calorific power, as low-grade coal. In some countries in Europe, we're already returning to coal. Why? I mean, we have sludge generated every day. Shouldn't we use that? And then the third one is, of course, the waste heat that is intrinsic in the sewage effluent, in the treated wastewater, which is warmer than the environment. It's usually constantly at 20 degrees. So again, with heat pumps, we can reuse that heat immediately or put it into a network. So I think these are the synergies in front of us. This is heat that is being wasted every day around us in a very scattered way. And actually very close to population, because the wastewater comes from people. So it's right there next to us.
Thanks a lot, Victor. Yeah, it's quite a striking data that the energy sector is using as much water as agriculture. I also didn't know. I don't know if you knew, but very interesting. So it's the next thing to look at, and I think with the wastewater treatment plants directive that was recently also adopted, we will look more into recovering this waste heat and making the water sector also as renewable and circular as possible. So that's also a very key aspect. Now remaining also on the side of the industry, we already heard that waste heat has a vast potential, and actually we are not really making the most out of waste heat for on-site. So I wanted to ask you, Valerio, what are the biggest obstacles to this waste heat recovery on-site? Do we have the technology, or is the problem elsewhere in terms of awareness, legislative framework? Can you tell us?
Thank you. So, I think we've seen that clearly the technology is there. potentially there are no limits to it, and we've seen how it is important to think differently versus how the heating and cooling processes were conceived up to now. Combining the two into one can have multiple benefits. One I forgot to mention before is the increased efficiency. These systems can be 4-5x times more efficient than having the two systems in silos. I think there is an additional benefit which is related to the skill force and the labor force. Over the past months and all the discussion there has been here in Brussels, mainly around heat pump deployment as part of the REPowerEU. One of the biggest hurdles that was highlighted was related to the need to reskill the workforce. This doesn't actually apply for large industrial applications because the service technicians, those ensuring the maintenance on large chillers producing cold water, they have exactly the same skills. They required exactly the same skills than to work on a heat pump and vice versa. So that there is an additional element there. We really see on-site recovery as a low-hanging fruit. I mean, everything, and we need to acknowledge there the excellent work that the Commission and the co-legislators at large have done in the regulations and directives we recalled before. Everything that pertains heating and district heating and cooling, I think it's great. Whatever possible, this should be deployed at scale. There are some objective barriers to it, which is essentially the need of building some suitable infrastructures and allowing, in some countries like my native one, some very lengthy permitting and administrative barriers to overcome. And this is why on-site becomes address these hurdles simply because there's no need of any particular permitting. The only thing you need is to think differently and combine the heating and cooling and reuse and harness the on-site, the waste heat that takes place within the same entity, within the same site. So, and this is of course much easier. It requires, as we said, and I want to stress, awareness. Awareness is the biggest hurdle and barrier we're noticing, even among people that should be aware of it. So anything that Commission, along with association and industry, can do together to ensure that anyone is aware of these opportunities, the technology advancements, and what are the benefits that could be achieved. And this is why maybe some concrete policy proposals, if I'm allowed. So it's really to try and refine and broaden the definition of waste heat that we have today in the different policies, to really include and encompass all possible applications beyond what is stated today, rightly so, in terms of district heating and cooling. I really like, even though it's scored 4th out of 4, so not very popular among the audience at least, I think that the sectorial targets is a good way to really measure the opportunity before, at an earlier stage, and then give sectorial targets. We know the industries that do have free heating opportunities on site. So nothing impedes to have, like we have for data centers, some dedicated and targeted objectives per large and industrial and commercial buildings. You name it, can be hospital, airports, hotels. I'll push at a level a bit, maybe too far, and member states may not like it, because in the EPBD there are some obligation in terms of net zero buildings for new buildings. Why not making heat recovery on site mandatory for new buildings? Because of course that will even avoid any possible barriers deriving from the retrofitting of a building, which is still technically possible. We talked about the awareness. It's important, fundamental to me. We heard as an industry some very positive news around the willingness of the Commission, of course, in the next mandate, starting from October, November, to really revise and revamp the heating and cooling strategy. We all know that there is an EU heat pump action plan, which it's somewhere in some drawers down the road in Berlemont. Why not, using this opportunity to try and identify a role, a more coherent and consistent role for all kind of waste heat opportunities. And last but not least, of course, the financial aspects, it's important. So there is two elements to it, in my opinion. There is the gas electricity difference in price, and this has to be addressed, I think, because overall it's then an impact, a negative impact that goes down to the customer and ultimately to the consumers. The second one is, of course, there's a lot of subsidies, rebates, incentives being made available from Brussels to the member states. I think to give indications to member states as part of the awareness-raising initiatives to channel these into the right opportunities.
Thanks a lot, yeah, and thanks for recalling. Now it's official. In this Sustainable Energy Week, the Commission official have announced the revision of the heating and cooling strategy. So it's official. Well, semi-official. It's a statement, but very, very encouraging also to take the broader approach. So to tackle the whole heating and cooling sector. So I think we also aim with this panel at inspiring what could be in there. And we spoke a lot about awareness. I wanted to go back. There are some questions already on the Slido. So there is a very technical question. Maybe we can kind of take this one first. It's for Victor. Let me find it. It's about how is the water injected into the ground in the borehole. They want to know whether. Sorry, I can't find it. Can we maybe put them on the screen? When inserting water at 40 degrees into a borehole, is the borehole a storage tank or is it inserted directly in the groundwater system? So it's a very concrete, practical question, and then we will go more into the economics, perhaps, of projects.
No problem. So actually, it's before starting, you need to do a geotechnical study and understand what sort of bedrock you have and whether it will be contained. What you don't want is that this water flows away and disappears with the heat and with potential pollution or anything into a water system. So no, it is an enclosed environment. It's the bedrock itself, and it's injected with pumps and extracted with pumps, basically. So it's similar in a way to what you do with geothermal energy. So, yeah.
All right. Thank you. I hope it answers your question. We also had a lot of questions that regards the investment costs and the business model. So one is addressed to Victor, but I think you can all kind of tackle this kind of question. So how quickly were the capital cost, in this case of the borehole or the heat pump system, paid off? I think it's quite interesting to show for industries that want to tackle this kind of project, how quickly do you get your money back? And you can start, but then Valerio and Andrea, feel free to jump in.
So the beauty of energy efficiency projects is that you get the money back from day one. So every single kilowatt hour that you save goes into your pocket. So the good thing about heat pumps is that they have this coefficient of performance. So usually if it's around 4 or if it's around 6, it means that you generate or you transfer 4 to 6 times more energy than the one you actually put in as electricity. So it's an effective way of reaching a return on investment. Of course, the initial investment is something that you need to consider. In the particular case of Emaboda, I do not have the data. That's a project that happened 15 years ago. But I could imagine that at the rate that they have been saving, around 100,000 euros per year, and it looks like it's a very stable operation. It will continue to be like that. it pays off very fast. So I think Andrea mentioned some return on investment before. Maybe you can comment on that.
Yeah, I was saying that as a business case, we wouldn't have invested into all those measures if the payback had been super long. So we did have typically 3 years or less on the measures that we implemented on our own site. And I just wanted to recall the hospital case that I showed beforehand, but the same goes also for the supermarket case. Is as you could see, or if you remember that graph, which looked a little bit complicated with the different colors, the hospital, by installing those heat pumps and by combining the heating and the cooling, they are now able basically to sell the heat in most of the months of the year, except the winter months. So that's a really interesting case because they recover it from the cooling system. So it's a real interesting business case which is perfectly replicable to other applications, and which of course then pays back immediately. Exactly as Victor was saying, it's from day one.
Yeah, I can only reiterate. I think we got experience of serving large multinational companies in different industrial sectors, and many projects. Speaking to my colleagues, many projects started off as we were called in by the customer, say, can you help me on this manufacturing side? And then the fact that soon later they asked and they wanted to deploy the very same technology across all the manufacturing footprint globally gives an indication that, well, if there is no convenience in it, people won't do it. They just simply change the overall thermal system for the sake of changing it. So there is clearly a payback, and as we discussed, financially this payback can be shortened in time, and almost to make it then the choice and the option for anyone having to either retrofit or creating a new industrial or commercial thermal process from scratch.
Thanks a lot, Valerio. There's a question on whether what to do if we have no district heating infrastructure. And Andrea, you would like to address this one?
Yes, I just saw that pop up on the screen, and I thought I'll jump on it because that's exactly what Valerio said beforehand, and what I also said beforehand. Of course, it's great if we do have a district energy network around and where we can feed in the waste heat, but it's not a condition. It's very well possible that you use the waste heat directly on site, specifically in those applications where you need both. If you have heating and cooling needs in the same application, then you can always recover the waste heat of the cooling and use it directly again on site. And there you don't need a district energy network mandatorily where you can feed it in. There are a lot of applications, or if you have process heat, for example, in industries, and if that process heat, I don't know, is below 100 degrees, for example, or the need for heat is below 100 degrees, then you can also recover the heat from the processes and use a heat pump to upgrade it to 100 or 120, 30 degrees, which is a totally mature technology, and use it directly on site again. So there also you don't need a district heating network around. So I think there are a lot of cases where you can combine the two directly on site, and that's perhaps also where we need if more regulation would be needed, then it would be to push those cases which are not so much being taken into account in the existing framework. But again, also there, I think the business case speaks for itself. It's about educating the market and perhaps giving those carrots in terms of incentives or tax breaks or better interest rates for credits or whatever it may be.
And stepping slightly out of my moderator neutrality, representing district heating here, we also aim at growing. It makes sense in cities Sometimes the industries are not close by, but sometimes now we see data centers that are within cities. So district heating is also a way to recover the waste heat at scale. Although it makes sense with the business model for waste heat to recover heat in terms of operational costs, sometimes the bottleneck can also be the investment into the infrastructure. So this is also something that we would like to see from the Commission and from the next batch of measures, is to really help the rollout of the infrastructure, and also from I think what Arthur was describing from this feasibility study period, because we know that it's very sensitive before the project are developed, when you're looking into the data, the sources available. So this is something very crucial. But obviously there is enough waste heat, and I think we use on-site or in a district heating. I think what matters is really to tap into it.
It's an issue of and.
Yeah, it's not or.
And
It's
absolutely. I think that there was a question, maybe more on the policy side, from Jonas. Will there be a measure on how efficient the waste heat is being recovered? This is in order to incentivize recovering not only part of the potential waste heat, and viewing this as good enough, but maximizing the potential. This is quite specific, but yeah, how do we ensure that primarily industries are being efficient, and then only perhaps like what is left is recovered?
Yeah, I think the Fit for 55 package is providing a framework together, not only renewables, energy efficiency directive, the buildings directive, but also the ETS on buildings and transport, will provide incentives to use only the energy you really need. In the NECPs, and we really hope that member states take this on board, the energy efficiency first principle should also be applied across sectors. That means that the argument that you can use as much as you wish renewable energy because it's you can deploy it locally. This is exactly what the energy efficiency first principle wishes to avoid. But it doesn't mean, I think, processes, you mentioned it in on-site processes, they are creating excess heat. And I think this will not change unless you change physics. For example, if you have a fridge, I think you cannot avoid having a machine with excess heat. But there the question is, how can we smartly recover and use the heat and make it, let's say, waste heat. Maybe there's at some point we can also talk about it with a nicer word than, because it's an energy source at the moment.
Yep.
And it's really to find the balance, and I think the legislative framework we have now can serve for it to be as efficient as possible with the use of hopefully renewable energy in future, and then to recover the heat that is produced through processes we cannot avoid.
Yeah. Yeah, I think it's quite clear that there is no business model in efficiency. The other side is, or the other way around, there is a business model in being as efficient as possible, because we saw the direct return, and the ETS is also there to make sure that, fossil fuels are having a carbon price. There is also something that I would like to discuss with you. It's not for specific panelists, but we know that there is an element of risk when we look into this wasted project. We know that in the red, there is already a hint on incentivizing member states to put in place this risk mitigation framework. And the risk is multiple. The risk is for the city when they start doing this survey on where the heat potentially is. The risk is also on these smaller companies where they are looking at project and they have this first investment before the project is fully viable. The risk is also on the wasted producer or owner. The data center can close or the industry can close. So what is your take on what could be done to tackle this risk? Do you see perhaps EU-wide mechanism? There are already private schemes, private insurance, also connected to geothermal energy, for instance. But do you see the need for this for waste heat? And I don't know who wants to break the ice on this.
I can perhaps start on it. I think, again, with the Fit for 55, we have a good starting point with the whole sustainable finance angle, which should draw also the attention of financial institutions and of banks, etc., on the potential of waste heat to mitigate the risk of, for example, like with the Ukrainian war, not having enough energy. So position the waste heat recovery as a way to mitigate risk, bring this to the attention of the financial institutions so that they would then also give favorable conditions to companies, etc., in order to use and recover the waste heat or to district energy networks. So I think to give this financial security already or support the uptake by providing stable or favorable conditions from a financial perspective, I think that's one way of tackling risk. And then from a district energy perspective or from a utilities perspective, a way could also be to have to use more of digital solutions as well, which help to better balance the different the supply of heat and the need of heat, to make sure that we, for example, balance peaks, that we store when possible and use the potential in district energy networks for storing heat as well. So really tap into the possibilities that we have with digital solutions, with artificial intelligence, to predict, to balance, to optimize, and by doing so to mitigate the risk of not having the required energy at a certain point in time, so that we can really, again, take this holistic approach.
Yeah, I would agree here with Andrea. I think the future of heat generation is a multi-source scheme. It will likely be a lot more complex than what we are used to when we have just a gas boiler. Leveraging digital is super important there, and then probably creating the right incentives for the buyer and seller. So creating an economy out of it. So I think it's still early days for data centers, but they should really participate in a heat market. I think that would be an incentive also to keep them in one location and to make sure that there is a return for them.
Great, thanks very much. I see that the time is running. Right, we were slightly over time, but I don't know if there are any final remarks that some of you want to put forward, or Arthur, please go ahead.
Thanks. Just a quick remark from my side. I think we talked a lot about business models and kind of the economic feasibility of all of this, which makes a lot of sense because it all falls with kind of what the business rationale behind of all of this. Maybe from the municipality's point of view, I mean, what we certainly experience is that, I mean, we know that municipalities will need to implement these plans, and many of them, of course, want to do that. They've got their decarbonization targets. But I think I want to draw a little bit the parallel to another conversation, which is the greater conversation, and I'm hearing some of this here, is that this need to accelerate the deployment of renewables in general, right? And here we're talking about the need to accelerate the deployment of, waste heat recuperation or district heating, heating and cooling, etc. And municipalities are essential for facilitating that process, as I've said, right? But what we also see in the different European countries, like depending on the size of the municipality, depending on the financial setup of the municipality and the regulatory enabling framework context that the municipality finds itself in, there's huge differences in terms of what municipalities can actually do, and I mean just in terms of staff resources. That is a general thing. When there is a lot of expectation now at the moment towards the local level to have a say and contribute to making spatial planning procedures and permitting quicker, right? To accelerate this initiative and all of that, and that is great. And we're certainly kind of in that process supporting municipalities in doing that. And I'm hearing something similar here. There's a lot of expectation in terms of the city to be the convener and to bring all the stakeholders together, engage in the greater picture and the greater planning. But there's a certain lack of capacity. If your people that you're paying to do this kind of work have limited contracts, or in some countries, the person who is responsible for the municipal climate change mitigation policies is on a 1 year or 2 year contract or something like that, right? Like, how are you expecting that we're trying with that kind of enabling framework for people, the public servants who work in the municipalities that need to actually do all of this work? How are we collectively expecting to meet those long-term targets? So the larger targets, but of course also the more specific ones. That's why specifically on heating and cooling, I think we need more, national level and regional level support structures within the member states themselves for the municipalities to move forward here. So with regard to the project which I just mentioned, we're certainly trying to do at the moment some support, of course, and this is done within the framework of a European project. You also see that many of the larger kind of project, and also some, by the way, larger projects with regard to waste heat use from data centers in cities or in collaboration with cities are funded or partially funded by European money, as it's larger projects, right? The question is really, how do you think long term, right? What can you do in the long run so that those that need to have the responsibility of coordinating all of this have the staff capacity to do it? And here really it comes down to finances, and it comes down to clear supporting structures for municipalities on the member state and regional level, in addition to asking them to do plans as an obligation, which is great. We definitely need that, but there needs to be done more. So that's a summary from my side also.
Thanks a lot. I think it's time for us to conclude. I'll just give you the key takeaways from this session. So as Arthur just told us, we need to make plans and do heat, if I may, and address this lack of capacity. So something maybe to take away also ahead of this heating and cooling strategy revision. Second, we saw that we need to raise awareness, so maybe that's also on us, on the industry, but also in collaboration with cities and the EU policy makers as well as national policy makers. And this also includes not only what we can export to district heating, but also the waste heat we can recover on site. Obviously, we need to deploy these technologies, the heat pumps, but also the district heating infrastructure. So also their subsidies, carrots, perhaps also sticks. We'll see in the next strategies to come up. Yeah, and I think this is already food for thought. And we are certainly not done with talking about waste heat to tap into the potential. So warm thank you to our panel and presenters, and as well to our audience on site and also online. Thank you very much. And for the on-site people, there is some brunch, lunch, some and a lot of waste heat in the room indeed. Thank you.